To solve this integral, we're going to use partial fraction decomposition. Partial fraction decomposition is an algebraic tool that we'll use to transform this integral into something that's easier to solve. All right, so the setup for partial fraction decomposition is we write the thing under the integrand. So here I have 1 over x times 2x plus 1. All right, so the thing to notice, right, is that the denominator has two factors. The denominator has that factor x, and it has this factor 2x plus 1. And so that tells us we want to write this thing as a, this is a number we're going to solve for, a over x plus b, another number we're going to solve for, over 2x plus 1. And now what we do is we multiply both sides by x times 2x plus 1. And remember, if you do the same thing to both sides, then you preserve the equality. So I'm going to multiply this side by the denominator. So basically we're multiplying both sides by this denominator. X times 2x plus 1. And I'm going to multiply this whole side as well by x times 2x plus 1. Now see what happens here, right? These will cancel so that we have 1 is equal to, now I'm going to distribute this whole thing to each piece. I'm going to distribute it to that and to that. All right, so this is equal to a over x times x 2x plus 1 plus b over 2x plus 1 times x 2x plus 1. Now look at what happens here. Right, this x will cancel with that x, and 2x plus 1 will cancel with 2x plus 1. And so we're left with 1 is equal to a times 2x plus 1 plus b times x. All right, enough. So now distributing the a through here to each of these, I now have 1 is equal to 2ax plus a plus bx. All right, so do you see how that worked? I distributed the a to the 2x to give me 2ax. I distributed the a to the 1 to give me a. So now going back up to the top here, we have 1 is equal to, okay, so now I'm going to collect all the things with x's together. So the things with x's are that and that. And I have 2ax plus bx, and then I leave this, then I collect all the things without an x together. In this case, there's only one thing without an x, so I just collect that by itself, plus a. All right, now using the distributive property again, but in reverse, I'll write this as 2a plus b x plus a. And now I'll use a little trick from algebra, from a theorem from algebra. All right, so notice that 1 is equal to 1 plus 0 times x, right? So, right, because 0 times x is 0, 1 plus 0 is 1, right? So I can write this as 0x plus 1 here. And now the theorem from algebra that I'm going to use says that if you have two polynomials that are equal, then their coefficients must be equal. So what that amounts to is that 0 has to be equal to 2a plus b, and 1 has to be equal to a. So that tells us that 0 is equal to 2a plus b, and a is equal to 1. Or 1 is equal to a, either way. All right, so now we know what a is, and we can plug that in to solve for b. So 0 equals 2 times 1 plus b, negative 2 equals b. So now we know that a is 1 and b is negative 2. And now remember where we started. All right. We started by trying to solve for a and b when we first did the initial setup and wrote x, 2x plus 1 is equal to a over x plus b over 2x plus 1. So now we know that a is equal to 1 and b is equal to negative 2. And if you want to check, you can add these fractions here, and you'll see that actually does give you that back. All right, so how does this help us? Remember, we're trying to find this, and now we can find this instead. So I'll split it over the sum. So I've got the integral of 1 over x dx plus the integral of negative 2 over 2x plus 1 dx. And now remember, a good thing to do is pull this negative 2 out to the front. I'll pull that out, negative 2. I have a 1 there. And now I can take the antiderivative. The antiderivative of 1 over x is ln absolute value of x. So we get ln absolute value of x minus 2. You could use a u substitution here for this integral over here with u equals 2x plus 1. If you do that, you'll see the integral is 1 over 2 ln absolute value 2x plus 1 plus c. And these will cancel, leaving us with minus there. And that's the correct answer.